right, so now we're going to start talking about how to look at categorical data. So instead of looking at numerical, we're going to start looking at ones that only have categories. So we're going to use a bar graph when we're talking about categorical data. Now, just as a reminder, categorical is going to be using bar charts or pie charts, but remember when we're looking at numerical, we're going to be using histograms. Okay, so that's the big difference. So here we have an example of taking a poll of people and we ask them, hey, which painting do you like? And then the way we coded it was we coded it by the color that they saw. So for example, if they liked a painting that mostly had green in it, then we would code it G. So here what we have is we have blue, so we had 6 people who liked that painting, 2 who liked the painting that had green the most, 10 who liked the one with the most red, and about 7 who liked yellow. So what we can do is we can look at the count or the frequency of each observation, add them together, and get how many we had total. So we had 25 total. Okay, now a key thing to notice here, is that we can reorder these categories any way we want. So what we lose is that we can no longer talk about skewness. So no skew when it comes to bar graphs. And the other thing is that we have less ability to really talk about variation. All right, one more thing is that we can still talk about the center or the highest value, and what that is called is the mode. Okay, so this observation here would be the mode, which would be red. Now a bar chart can have 2 modes, but they have to be exactly the same count. Okay. So another way that we can look at organizing categorical data is using a pie chart. So even though pie charts are great, we usually don't use them in statistics because they're lacking, they usually lack a lot of information like percentages, counts, things like that, and they can also be misleading depending on how people make them. So, for example, we took the above data, but we put it into a pie chart using StatCrunch. Okay, so one reason this is misleading is because the colors don't match with the colors that were in our observations. So for example, this would be blue, well, green matched, red, no, and then yellow. So if we just look at this, blue and yellow look very, very similar because they are, but we might mistakenly think that they're exactly the same. Okay. So if we look at the next example, let's say that we have the following observations of something, okay, and what we do is that we code the weight and the color of this object. Now here's the deal. If we want to get a visualization of this data, we have to decide whether we're going to use a histogram or a bar chart. So for the weight, this is numerical, which means we would use a histogram. You could also use a dot plot if you like, but I'm a bigger fan of histograms. Now color, is a categorical type of data. Therefore, we would use a bar graph, or you could use a pie chart. The dot plot and the pie chart aren't usually ones that we like to use, but still capable of using those. Now, the next thing we're going to be talking about, 2.4 might as well be just 2.3 continued, is variability. So, if we are looking at these two schools, okay, we can talk about their variability because they're very different, and we can also compare them. So, it looks like school A has more variability than school B, which has less. However, they both have the same mode, which would be Hispanic. Okay, now let's look at a different way of visualizing data and talking about it. So let's say that in the next example, we're looking at the causes of death between males and females. Okay, so what we have here is motor vehicle accidents, other accidents, homicides, suicides, disease, and other. Same thing for female deaths. So what we know is that if we look at both of these, they're both going to have a mode of motor vehicle accidents. Now here's the deal. If we were to look at the differences between the two genders, it's a little difficult, and here's why. Even though these are in the same order, the causes of death are in the same order, if you look at the y-axis, it has different y-axes. So it's hard to compare them directly without doing an actual count. Okay. Also, what might make it a little bit difficult is the proportion. So we have other accidents are high for men and not so high for women, but proportionally, this isn't any higher, it looks like, for disease or other for men, whereas other accidents such as, or other accidents, homicide and suicide, also aren't that high for women. Okay? All right, so they have different y-axes. They have different percentages in each category. Also, look at all of the men's heights are a lot higher, so men die more often. So I think where this data came from is it's deaths per 100,000 visits to a emergency room. So what might help us instead is if we look at them on the same graph. Okay, so if we look at them on the same graph, what we can see is that women definitely die more or die less than men when they visit the emergency room. Okay, so who has the overall higher fatality rate? Men. But we can also see that they have more similarities than we thought. So we have about the same number die from diseases and other. So there's similar counts, even though their proportions when we looked above were different. Okay? All right. And last but not least, let's say that we want to compare these two graphs. Okay? So what happens is that patients are arriving at an emergency room and they're having trouble breathing, and they randomly assign them to either lie on their backs, which is supine, or on their stomachs, which is the prone position. So for each of those, the graph displays the number of patients who died from acute respiratory distress syndrome and the number who did not. By the way, the word acute, I know it usually means small, but in the medical field, it can mean sudden. So like serious acute respiratory syndrome, SARS, it's serious, acute means that it comes on quickly. So if we look at this one, for prone position, we had about 80% alive, while we had, this looks about 20% died. Whereas in supine, it looks like we had 70% live while 30% died. So if we were to go to the hospital and decide, hey, which position do you want to be on? Do you want to be on your stomach or on your back? Well, You would like to be on your stomach because it has a higher success rate for survival. Okay, great. So that is it for us. We are now going to move on to section 2.5.